see, I'm going to turn the air down. Let's turn it up. So it actually, it's like it's, if I turn the valve off to the air coming in, it starts building up pressure and we get this really nice orange flame out the top of that thing. A really nice one, actually. Man, if I had more pressure, this thing would be cooking, man. I know the light's really bad for you guys. Let's see if I can switch angles here. And not get the back. Oh man, that's a heck of a flame. Holy macaronis. That looks beautiful. I'm running at 15 psi. Now I'm going to take my temperature gun. The disc is ambient temperature. And then let's see if I can get like a... I'm going to try to heat up a piece of metal or something, see if I can see the temperature change in the metal. See what my cell's running at. Cell's getting hot on that side. Let's check this side. This side I've been reading the whole time. Yeah, we're at about 110 on my cell. Yeah, but my containers are only at 95. Man, that's a flame right there. That looks great. Alright, let's see if I can heat some metal and see if I can get a temperature reading on it. Okay, Crooked, that's enough. Yeah, I need a bigger piece of metal for that. I melted it. Nice. This must be some interesting aluminum. Come out of a hard drive. Okay, Crooked, I had enough. Quit it. Go away. Alright, now here's the question. The question is, can I shut that off and touch the disc right away and not get burned by the disc? Alright, so here we go. I'm shutting this off. I'm shutting this valve so we can touch it right away. As soon as it pops. Ice cold. Let's take a temperature reading. Check that out. Oh, it's hard to see. Ambient temperature, basically. 96 degrees. Not even warm. So you can, because the flame surface is never really touching the disc, it never really gets hot. So that's something to think about. Pretty cool. Now, just for fun, we're going to try one of these that Fire Pinto sent me, and we're probably just going to let it melt. See, I'm sure it's going to get super hot, and we'll just let it melt. I want to see what happens. This will be fun. Alright, peepholes. I wonder if with what? 15 millimeter hole, if that would handle the low pressure better. That's really cool, man. Let's try this other disc we got and see what happens. Well, we learned something today, boys and girls. And I hope you paid attention. Good job, Electro. Nice work, buddy. It paid off. Paid off real well. And we can customize these things. It's even better. You could put that right on the end of anything you wanted to, and it wouldn't even care, man. I mean, it would never get hot. And then you could heat, you know, something else like a ceramic plate, something that wouldn't burn, basically. You know what I'm going to do before the night's over? I'm going to run some ionized air through that thing with it. See if we can see any different results now that I've got a good controlled flame. A little bit more pressure than last time. Okay, now this is going to get real hot, and I know it's going to get real hot, and I'd like to see how hot it gets. That's right, you can even make a custom tip. It's awesome. Alright, boys and girls, time for this thing. This is a breather vent, basically is what it is, or a dampener, depending on what you use it for. And I just want to let this thing get super hot. I want to see how hot it gets, because I have a feeling it's going to get really hot. So I'm going to go ahead and turn it on. And because the flame isn't off the surface enough, I'm afraid it's going to get really hot. So I'm going to go ahead and light it. Oh, look at that. Well, that's kind of cool. Hey, at least it's not flashing back. See how hot it's getting though. 200, 50, 300, 400. See how low. It's all the way up to 170. So you can see it's already getting very hot. Look at it, it's getting black. Look at that, it's getting so hot it's melting the... Should probably stand behind something in case it blows up. It's going to hit me in the face. Alright, I'm going to shut it off. And come on, it's getting red hot, man. It's actually melting the... It's at 600 and it's just over 600 degrees. So, in theory, if we're going to make this work, it's got to be enough pressure to get up above the surface. Yikes. What's up, Sharky? You know, it'd be really neat to see that change colors. So why don't we take that one off and put a new one on and watch it change colors. That'll be fun, right? I'll try to get you guys a little closer because you guys can't see a friggin' thing. I'm sorry. I'll get you a better view here in a minute. There you go. As long as it don't fall over. Alright, so I would be really interested to see this change colors. And so that's exactly what we're going to do right now. Pretty cool looking little flame at the beginning there though. You'll have to watch the... Oh man. You'll have to watch the rerun though. Man, that worked, but got a little hot. Just a little hot there. We'll try the fishing thing. I bet that's going to get real hot too. Or the fishing stone. Now the point really is to quench the flame, and that successfully did it. Hold on, I'll pick you back up here in a minute. After I get this on here. And this one doesn't look as healthy as that other one. Alright, children of the world. The point here is to quench the flame, and interestingly, you know, we quenched the flame. But right now, what I want to see is I actually want to see how well this does. I want to see this thing get hot. I don't want to see it change colors. So, start your mark, lighting the flame. And now, I'll check the temperature too. 200, 300, 350, 450, 500, 615, 620, 635. And at this point, it scares me because if it pops, it's going to melt and blow my face up. But we were at 675 plus degrees Celsius. No, Fahrenheit. That was Fahrenheit. So yeah, that was kind of cool, actually. Kind of neat. Yep, I'm not gonna sit here and talk to you about that. That was interesting, to say the least. Now, I got a question for you. If we lit one that was this small and we had more pressure, is it going to do the same thing, or will the flame get above it enough to not heat it up and melt it? Let's find out. Alright guys, so I've got this little bitty one, and I would like to see if it'll melt versus what we just saw right there, because obviously we can tell that that's not the best thing to happen. Man, I've been wanting to do this burn rate type of testing deal forever, so this is awesome. I got some more stuff I want to do today if we get to it. I'm not 100% sure we'll get to it though. Ooh. Got a lot of moisture and water in my line. Matter of fact, I got a bunch of it in my line. I'm gonna have to do something about that. So, time out. We'll drain some of this water out of my line. You can tell it's got some semi-nasty crap in it. Bunch of moisture building up in my system. So I'm trying to bleed it out a little bit here. Water is, I don't think the water is boiling, but it's warm. Alright, that's a bad thing. It's got chemicals and all sorts of crap in it. I hate that. Just from the water solution I got there. Alright, let's, I'm going to zip tie this one, because it ain't going to stay. As a matter of fact, I'm going to zip tie it. Well, I have to zip tie it down a little bit. Alright, perfect. Let's see what happens. I need to stick this flashback back in here. Okay. I'm gonna wipe my desk off. Now let's see what happens. Alright, boys and girls, I got this little one set up, and I'd like to see if we get the same result or if we get a different result. I want to see if this blows off further or less or what. So here we go. Looks like it's getting pretty hot there, doesn't it? Oh, you know what though? It's staying, look at that, it's staying a little bit cooler. See what it looks like. Oh no, maybe I lied. Looks like it's getting a little warm, huh? That's great. Oh! Oh, crap. Now this is going to flash back. I'm going to stand back and watch. Oh! That was cool. And cut, right? Okay. So for instance, I'm not too concerned. I'm going to knock that off though. I'd much rather melt the carpet. Alright. Let's inspect the damage. First of all, the whole tip got very, very hot, as you can see. Melted my hose, which I figured would happen. But, let's see what this thing looks like. So the answer is, it blew the hole in it right down the center. Can you see that? And that's going to be some cool playback footage. So, it definitely splattered a little. I felt it splatter, and I was kind of afraid of that. Very interesting. So yeah, that'll be a fun rerun. Did you see that flame coming out of that thing? What the heck was that? You know, though, it never really flashed back. I'm going to see what that looked like really quickly. I'm kind of curious. I think I had the lights off, so we should have seen it explode. I guess it finally broke through and then it blew all the way. That was very interesting. I love the squeal. I don't know if you can hear that in the camera. That's great. That's my laser there. That's great. Oh yeah, it's glowing red hot, man. Oh, I love it. I love how it got so hot it just fell over. That's good stuff right there. I thoroughly enjoyed that. That might have to be a separate upload. And that's why we test and test and test. Alright. That's hilarious. I'm gonna plug the camera in. Alright. Let's see. I got the fish thing to try before I put my camera up for a moment. Now, I'm gonna have to find a way to introduce the gas. And because I've just got this stupid ceramic thing, I don't quite know how to make it work, if you know what I mean. It's got these little rubber. I guess I could just leave these little rubber things in there and we'll just try it and see what happens. That's actually not a bad idea. We'll just do that. So I'm going to take this off. And plug that into there, and we'll get a 1/4-inch tube. Here we go. And we'll just strap it on here, I guess. The results of this are going to be very interesting. Ta-da! Okay. It's going to burn a bunch of stuff and melt some things. I'll tell you what, I'm going to lean it off the side. At least maybe we can keep it from doing that. I just want to see if it works. That's all I care about. Well, those of you who made it this far, because it's probably a pretty long video, that was great, that last one. Now this one's going to be even more interesting. Basically what I have here is nothing more than a fish tube breather thingamabobber, and really I just want to see what happens here. And I'm going to turn the lights off to light this. That looks like okay, I can take that off. Right, cool. I'm just gonna light this. I really just want to see what happens. It should not blow backwards, but it's not going to be real pretty. So I am going to turn the lights off. Go ahead and turn the gas on. And I'm going to stand behind the camera. I'm going to light it and probably turn it off right away. Here we go. Alright, so it's... Man, that's quite interesting. It's just this really giant hot thing. You can see it's burning the edges, so I'm going to shut it off. Oh, the whole thing's going to fall off. Come on. Alright. Well, you're not going to be able to see it, so therefore I'm going to turn the lights back on. That was rather interesting. The whole thing got warm. Let's check it with my temperature gun. It's 160. Here's what I'm going to do. I'm going to do that again with the lights on. And I'm going to check it here with my gun so you can see what temperature it is. That's rather interesting. Alright, sorry you live show folks, it's going to be hard to see. Alright, here we go. Alright, power's on. I'm just going to hold this on here so we can see it. No visible flame whatsoever. But we're putting off heat. So actually a really long ceramic tube like this, as long as it didn't overheat and blow up, man, I can feel the heat over here. That's impressive. It's just a giant, it just puts off a bunch of heat. Now I know the ends aren't sealed very well, so my rubber is probably going to try to melt. So I'm going to turn it off. But the fact that that just puts off an abundance amount of heat is pretty darn cool. Very interesting. And the whole thing's just hot. And you can tell it melted. Look at that. It turned that hard piece of plastic into a nice soft plastic. Oh, that's great, actually. Look at that. Like the perfect melting temperature for that plastic. Awesome. I bet this side's like that too. It's definitely hot. Alright, so now we know that if we can get that to... Man, that's interesting. Now we know how to just put out a nice amount of heat if we want it. Man, that thing's still hot, and it worked great, but it's still very hot. 300 degrees hot. That's interesting. I didn't expect those results. I wonder how hot it would get before it melts or cracks. That would be the problem. But you can see I melted the inlet too a little bit. Not like the outlet. Check it out. That's pretty cool. Okay, well, there it is. I have tested all my things I would like to have tested. Now, as you can see here, these stainless steel mesh discs also got hot. See that? Now, what we can do is let's go ahead and do that again with this disc. Let's try one more time. Let's see how hot this disc gets, because I never really let this burn long enough to get overheated. So let's try it. Alright guys, so last thing here, we're going to try the stainless steel disc. I want to see if it overheats. Basically all it comes down to is, will it get hot? I never had the opportunity to check it, because I never had the heat gun, but I went and got me a heat gun. Harbor Freight, I know, Harbor Freight special, but here's the deal. I found a coupon in my magazine, and cool thing about that is it was actually $10 even cheaper yet than what they were selling it for in their magazine, or in their whatever you call it, ads. I got like a weekly ad at Harbor Freight. Okay, let's see how hot this one gets. Alright, here we go, guys. Alright, guys, original quenching disc. Thanks to Han Solo 1. I hope I said that right, buddy. He donated these a long time ago, and they work great. But now we're really going to see what happens. We're going to see if they get hot. We're going to let it run. We're going to let it blow up if we have to. But let's see what happens. Well, there's the first thing that happens. Now this disc isn't sealed very well. You can see it's already I'm pointing my laser at it. Alright. That's almost scary. Alright, shutting her down. I'm afraid that got real hot. Not quite 400 degrees. Nonetheless overheated. Hey, Tin Man. What's up, buddy? I still hear it. Shut it off. Alright. That was interesting. Now we know what happens. It gets too hot. Alright, Tin Man. You want me to show you what we did today? I'll show you. Check this out. This is pretty sweet, actually. I'll hook this other disc back up so you can see what we did. We're testing quenching discs today. And Electro over there in Sydney, where you're at, created some discs for me a while back. And I never got the opportunity to test them. So we did that today, and I will show you the results. That whole tube's hot. Alrighty, so looks like success is a good thing. It does work. Yeah, I know you are. I know he is. Alright, Electro, I will use my zip tie this time. Zip tie it so it doesn't fall over. Now that I know it works and doesn't get hot. Alright, Tin Man. I'll get you a close-up. I'll get y'all a close-up. Everybody, now that I know it. Now that I know it works. I'm going to turn the lights off again. Here you go. Camera will focus after I get it lit. Just wait till I get it lit. Oh man. Probably gonna knock the camera over. Hold on. Ooh, so pretty! And that looks like my camera won't focus because I'm probably too close. So I'm going to get it to focus. I turned it off. I think we had an over. I think we had a looks like my blow-off valve. Looks like we hit 15 psi. That's alright, I can turn back on now. I bet we have water in our system. It's not allowing stuff to get through very well. Kind of scared me. Shutting it off back there. It's bleeding out. Check out that cool cut right there earlier I did. It's so clean. Well, it looks like our hydrogen experience might be over for today. Looks like I sprung a small leak. Gonna have to fix that. I think I'm overpressuring my system. Time for a little cleanup. Chemicals. I hate these putting chemicals in here, Tin Man. I'll have to try your grid way, man. I'll have to try your grid, but if I did the grid way right now, it wouldn't work in this system. Holy cow, he says. Awesome. Alright, time for a little cleanup, looks like. Need to get some vinegar, to be honest. It's about the only way to clean this stuff up. Cool thing is I can just bring this outside and just hose it off. I mean, like the whole thing, I can just hose the whole thing off. It doesn't hurt it. Look at that, it's still lit. Oh! Awesome. Still releasing pressure. That's still lit. That's great. And Tin Man, what's cool is that you can just put your hand right on top of this disc right now and nothing. No heat. There's no heat generated. There, it finally went out. Alright, looks like I'm going to be doing some cleaning. So you're just going to have to hang out. I will make a conclusion of my experience. But I'm going to hose this stuff down. Yummy. Oh yeah, I got all wet too, but that's okay because that washes off well. Interestingly, this sheet of plastic came from a actually came from the front of one of those big screen TVs, and it's chemical resistant and everything. It's really wild. And let's see what my 110 degrees on myself. Water temperature's just under 100. It's not bad. Definitely not the best. I'm gonna have to go outside and leave you guys hanging for a while. So I'm gonna go ahead and spray all this down while it's wet, because if it dries it gets really gross. You're gonna have to deal with it. Yeah, it's a dry stuff. Brute force. My what happened here? My hose. When these suppressors, these flashbacks get wet, which is what was happening. I was getting moisture in my line. When they get wet, it's not a good thing. That's what happened. Stuff got wet. That's why I got this drip pan, because otherwise this stuff would be running all over the table, and luckily it just sprayed a little. I can wash that up. I can wipe it off. Alright then. I'm going to shut these lights off so the bugs don't come in. Hey, it's getting light outside. I guess the bugs won't come in after all. Nice. I didn't realize what time it is. I'm so used to doing late shows. What chemicals? It's just KOH. It's I'll show you here in a second. Hold on. I'll show you exactly what it is. It's starting to rain from earlier. A little clean up. Clean up, clean up. Everybody clean up. La 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 land. Patience, children. Just because you don't see me work doesn't mean I'm not working. It just means you're not paying attention. Haha! Why not straight water? In this system, to get the amount of output that we're looking for, it won't work with just water. This system was designed to run on brute force DC with chemicals, so that's what I'm doing. Bill Williams designed this for separating hydrogen from oxygen for his tests. So that's what I got. I got what I got. Oh man. I got what I got. That's what I got. And that's what I got. Got it? Yeah, you finally caught a live show. Good job. Yummy. It's always good to give this thing a nice wash down. I like it because you can just wash it off. Most systems, if you just covered with water, they'd be in bad shape. But with this one, you can just spray it off. And done. Oh, it's just lightning. And I'm out here playing with water in the yard. Sounds like a great idea. Great idea, Russ. This is not any worse than playing with the hydrogen. Ooh, you got some thunder. We got pure hydrogen though, we can still play. Alrighty, almost done. Almost done. La 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 la. Okay. Now all the grass will probably die, but I don't care. Somebody's got to do it. Oh yeah. Finally got something done. Feels like I haven't been able to touch anything for months. I hate that. But that's okay. One step at a time. Patience is the key, people. Patience is the key. Hey, I'm back. Okay, what are you guys doing? I'm back. Can you see me? Hey, you can see me. Alright, I'm just mumbling to myself. So, yeah. I gotta grab this thing. I'm not real sure what this plastic's made out of, but it is awesome stuff. It doesn't scratch. It's chemical resistant. Like, the chemicals melted all my other plastics. And it just dried on here, and then I wiped it. Tin Man, you still listening? Sodium hydroxide. This is the crap I use. This is what Bill called for. This is what I use. We're working on other systems, but that's what I got right now. That piece of equipment actually is pretty darn cool, and it works. But it's like any homemade piece of equipment. It's got its limitations. Somebody's over in the other chat room. Bad stuff. I know. You are correct. That's what I got to work with at the moment. I think if I had to put that through a bubbler, it would have dried it out a little. Put it through a dryer. My gases wanted to come out wet. I'm gonna have to clean that with something. Okay. What else do I want to do? Yeah, no, they haven't. I had a bunch of stuff I wanted to do, but I don't remember what it was all going to be about. I think I want to hook pulse fire up to my pulsing coils here and just do some tests. I don't know if I'll get to the tests today, but you missed it, Tin Man. That was great. That was great. I did some funny stuff earlier. I think I'm gonna eat some cereal. What time is it, Tin Man? Electro said it was about 8:30 earlier. It's probably about 9 something, but oh, I got some very fun footage to post for you, Tin Man. Oh, you missed what? You'll just have to wait and see now. some funny stuff. Yeah, so you guys are about 2 hours difference. Mmm. This is a heck of a device, though. PPG is pretty cool stuff. Look how clear that dried. That's some cool stuff, man. Yes, I have, Tin Man. Yes, I have. I'll have to post some footage. I gotta edit it first. Maybe I'll do that. I'm gonna hook this box up. And maybe I'll edit some of my other footage so I can post it. Oh, darn mosquitoes. You freaking kidding me. I hate these things. I tell no stories, you just have to wait and watch. It's funny. I had a good old time with me, myself, and my fetch stick. I'm missing like half the nuts. What's up with that? What are you doing now, Tin Man? What are you building? Are you working on something? At the moment? Yeah, what are you doing? Wrapping coils? How you like your new job? I heard you bought some of those coils. Yeah, I bet. All the returns go in the bin, don't they? I know how that works. My wife's mom works at Ace Hardware, and when somebody returns something, it goes in the trash. It's great. It'd be something as simple as like batteries not working right, but they can't repackage it and resell it, so they just throw it away. It's unbelievable, actually. Yeah, that's a huge waste. But that's the way it is. Everything's disposable nowadays. Just buy a new one. It's trash. You know, it's kind of dead boring right now. I need some freaking music, yo. And I need to find the rest of my nuts. I think we should fill this up with argon. And turn it on so we get power out of it. Yeah, I lost all my nuts. You know what I'm gonna do? I got some connectors. I'm gonna have to go get them. I'm just gonna put all these on a connector. Be done with it. And then I can plug it in when I want. That's exactly what I'm gonna go do. Coffee time. I'll be right back through. Oh! Sharky quit. Couple of cracks. Oh, what are you guys talking about? Good stuff. Alright, I got some connectors here that I'd like to use for this. So, I got a block of steel out so I can put my camera on there. Awesome. Oh, you know, I forgot my laptop. That's okay. Alright, I'm going to dig these out of here. I think that's it right there. And basically, Lucky Charms, gimme. I got a bunch of connectors here as a donation, and I'm going to use it. I've been wanting to put them on here for a really long time, just haven't had time to do it. So now is a good time. Sorry, I did not do much lately. My work has been allowing me to spend time. Hey, no problem, my friend. I haven't done nothing since probably we talked last on the VIC, man. I haven't had time either. Haven't had time. Oh, your browser crashed. Hey Sharky, I would like to talk with you though when you get an opportunity. Look at these nice connectors. Heavy duty. So I'll make me a bracket and mount this one on here. And I will just use this one to plug it in when I want to do testing. I'll probably just end up leaving it hooked up to the Pulsefire box. Yeah, it does, don't it? Here's a bigger one. Actually, it looks just like it, doesn't it? Now you mentioned that, it looks just like it. It's probably from the same age era. Oh man. Alright, I gotta count my wires here. I got 12 of them. Oh, and this has 14 pins. The small ones do. That's perfect. Awesome. Yeah, Sharky, I love to catch up with you. You get an opportunity. Let me know when what works, and I'll try to make it work. Okay, let's see here. I don't have the necessary tools to properly wrap these things. I'm gonna have to do one at a time so I don't get them all mixed up. You guys really should be back further, huh? I can't see really what's even going on. There, how's that? Can you still hear me? More better? What? Oh yeah, you still have questions, don't you? I'm so sorry. I never replied to that email, but you know what? It's funny because I do remember. I have about 30 of those emails that I know I need to reply to and have it, and then I have about 120 bazillion more I haven't had a chance to respond to. Oh, okay. Okay, here. I need to write down a scheme. Pencil and paper would be nice. Oh, actually, if I just put them 1 through... Oh no, I still have to do that. Yeah. It's funny, I've had these prints from the injector that day I did that video. They've been sitting out here, and the backside of all these prints have been my notes for a while now. It's kind of funny. So we'll just go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1 is green, 2 is 1 white, and then green, white, four, 5, 6. Okay, good enough. Did you get some coffee? 10 men? Sharky, I've looked over those things pretty heavily, and Chris and I re-engineered that whole thing. Rebuilt it in 3D. I pretty much can guarantee you that we're not missing any internal connections, just from what I've seen. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Whoop whoop. So 10 men, did you get the lathe running? Or, because last video I saw the gears are falling off and I laughed really hard. I mean, it was hilarious. Halfway up the outside of the inside, there's a set screw that holds the Durlin cap in its place. That's a set screw. Alright, let's see here. I think what I'm going to do is mount one of these on the side of this. So let's see, where's one? And that's going to make this really difficult. Trying to get those inside of here. Yeah. Let's pull these out on top. Keep going, Sharky. I'll answer as many questions as I can. I gotta see which one's which now. I guess it don't matter. You put them in either one you want. That's cool. I'll just put this side on this side. See, they make a tool for these. Crimp these in here. But I don't have such a thing. So I'm going to solder them. And they'll be just as good. Alright, so that is one white. Plugging that into two. Oh man, I'm gonna need like a small pin or something to push those in there. Oh, you know what? Little crap. I got these little things and now I can't get that out. Oh, maybe I can. Oh well, it'll be fine. Now let's just put this one on this side. I want to see if... Oh, I better wait. Man, these mosquitoes. What the heck? Sharky, you still out there? Alright. Number 1. This could take a while, but when it's done, it's gonna be awesome. Let's see here. Yeah, I'm gonna have to get a needle or something. Yeah, this might work. Hold your breath, I'm gonna sneeze. Oh. Much better. Alright. Let's see if I can push it in there with this. Oh man. I have no idea how I'm supposed to push those connectors down that far. I really don't know. Oh, I gotta get them. I gotta get them all the way past. Alright. It's gonna be great when it's done, but it sure does suck right now. Oh my. I'll have to look. You talking about the bottom? The screws from the bottom? You know what you need to do, Sharky? You need to wait. We'll get those out, those drawings out really soon. Almost done. I gotta make a disclaimer on them so nobody gets mad. And then we can post them. And then you can visually see exactly what you're missing. Does that sound like a good idea? because the drawings are pretty much done. I have to get back with Chris. I want to put a disclaimer on there, basically, so nobody. We were going to try to open source license it, but that ain't going to happen. Really, it comes down to having a patent. It was at one time patented, so that's the issue. I ain't worried about it. Whoops. Thundering outside. Man, I really can't get those in there. No. I got a needle in my wallet. Let's try the needle. Oh, that didn't work. How in the world am I supposed to get those latches past that? Oh. There, I got one. Maybe it did go through. These are stupid. Yeah, you could do that, but the thing is, if I do that, I'm not going to be able to get the connectors in very well, or at all. Well, son of a gun. Well, there's one down. Wasted. Okay, Tin Man, I'll do it your way. It's really stupid. Never seen that done that way. I've always pushed them in the back. Always. I think what it boils down to is I ain't got the right pair of crimps for this. And it's not crimping very well. Alright, whatever. Whatever. Oh, fine, I put it in that way. Are you happy now? I guess I could cut them all off and poke them through there. If I get them mixed up, I'm just screwed. Now, I did obtain a 1 horsepower overhead valve 4-stroke engine that I'm modifying as we speak. Sort of. I have to actually have it in my hands to do it as we speak. But anyway. And I will be playing with that on hydrogen and a few other ideas. Yeah, it kind of worked. It worked. I just I didn't want to do it that way because I have to force it in here backwards. I didn't want to do that. But it worked. Blah, blah, blah. Alright, number 2. Ooh, it's raining again. I love rain, dude. It's been raining here forever. Alright, 4 is too white. I got so many of these little crimp things, I should probably invest in one of those tools. It would be a lot faster. Yeah, I got that genset. It's 7 horsepower, and it just seems like it's a power hog, man. It needs a lot of HHO to get it going in a standard running on hydrogen fashion, if you will. We did this a little different. Got our gases all mixed right. I don't think it would be that big of a deal. Alright, 4 down. Now we're gonna go to 3 green. This will be real nice when it's done, though. I've been wanting to do this for a really long time, and I just haven't had the time to do it. So now is the time. So, Tin Man, what do you think my idea of just being a solid state device for the PAP engine? Who cares about mechanical movement at the moment? Why don't we use the old school electric motor and just create power to charge up our supercapacitors to run our electric motors? Wouldn't that be a lot easier than attempting to design a system to make a piston go at the right RPM to get everything just right in a motor application for a general person? Yeah, but let's not say the big. Let's not. Well, okay. Let's say we do use the big magnets. I think that if you put some shielding material on the back side of that piston, depending on what your cylinder's made out of, I don't think it'll be a problem. But if your cylinder's made out of aluminum, you're going to have a problem. And I think I did hear that you're supposed to use aluminum. So that might play a huge factor. But what if you had a... I got a question for you. What if you had a cylinder with a piston out the end of it, you mounted your magnet out there, and then the entire device was encapsulated in something where it was never going to be, like glass, for instance. You could fill the entire thing up with the equal amount of noble gases, and then it would just do its thing. And you wouldn't have to worry about... I'm just worried about the gases leaking past the seals. So if we close the system in a box, fill the whole box up with noble gases, it shouldn't ever have a problem. I mean, I'm just thinking out loud here, but... And I see this thing being a solid state device rather than being a motor application. Yeah, well, here's the problem. At the moment, the problem that I see is that if we use some sort of a Teflon or plastic ring for the piston ring, you know, running a piston will be great at low RPM. Once you get past a certain RPM, it's not going to work the same. It's going to get hot. The piston ring is going to get hot. But if you were running, let's just say it's 60 cycles a second, which would be equal to what, 60 RPM? Or is that 120 RPM? But anyway, if you ran it at low RPM at like 60 cycles a second, it would be the same, or for you guys it'd be 50. You'd have your exact AC sine wave power generator right there. I guess that's what I'm looking at. Yeah, they'll work for a while, but when they're dry, they're going to wear out. Anytime you use a hydraulic, you're using liquid. There's a constant lubrication going on there. In our case, we won't really want to lubricate it all the time like that. We want to leave it dry. 60 cycles is 360. No, One past, one back. No, that's not right. You got that wrong. No, that's not right. I don't believe you. That doesn't look right at all. That doesn't look right at all. We're not spinning in a circle. We're going just past the coil and past the coil. 1, 1. So 1, 1, 1, 1. Yeah, 60 cycles. Yeah, okay. Sorry, Electro, you're right. But I meant a minute. My fault. Tin Man corrected me. My fault. Per minute. My fault. So what is it now? 120? Or is it just 60? Or is it half that? Is it 30? And then boom, you got your electricity right there. You just keep it steady at that RPM. Boom, 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 boom. You're done. You don't even have to worry about it. Screw mechanical power. Use old school electric motors, man, or make your own. You know what I'm saying? Like, use what we have to make it work. We already have electric motors. We don't have to redesign the engine to make it work. Screw mechanical movement. Gain that through electrical. It's my opinion. So much easier. Yeah, that's exactly right. 120. We can do that. That's easy. 120. Think about it. That's easy. I mean, that's just my thinking. Now, Tin Man's design on one single piston pushing a circular motion, maybe you could use that for a water pump or something, you know, that you would need that up and down motion. You get a water pump, you can make a standard up-down pump. I mean, that's perfect. And if you needed motion like Tin Man's deal, that's great, but it's so much extra work to seal everything and get it to work right. Yeah, I know you're thinking to replace car engines, but how are you going to control the RPM when you're just flywheel spinning 100%? You have to use a clutch or something, or variable transmission. But I'm just saying, if you got an electric car, slap this thing in your trunk, charge your batteries while you're running. Screw mechanical altogether. I mean, I'm just thinking out loud here, but does that not seem a heck of a lot easier than trying to design a system as a general person on this earth to get that system to work 100%? It seems ridiculous. I mean, I'm not saying we can't do it. I'm just saying what's going to work the easiest in the shortest amount of time. That's all I'm saying. I know we can do it. I have faith in that. I built my own electric motorcycle. Guess how much I spent? Negative $36. I walked away with 36 bucks and a full functional electric motorcycle, so I'm not too concerned about everybody else. I'm going to say, hey, look, everyone else, this works. You want to apply it to what you're doing? Here it is. If you want to try to make an engine out of it, this is how it works. Good luck. Think about it. You're going to have to replace... Think about this, Electro. If you have to design a whole new engine just to make this thing work, you got to design a whole new noble gas engine and replace your old school gas engine with it. You might as well just convert it to electric. Alright? You might as well convert it to electric if you're going to go that far. Think about it. Then you ain't got to worry about all the mechanics. The mechanical side of things. I mean, am I seeing this wrong, or does this make sense to anyone else? Four more wires left. Hey, Tin Man, you're right at the beginning of saying get it to work and then think how to use it. That's right, but it's always good to keep in mind what your options are, so that when you go about building a prototype, even just to test your theories, you may be able to easily convert that into something useful without spending too much extra effort. Just an opinion. It's always good to think about how you're going to use it, even though you need to still prove it to work. I agree, though. Electric motorcycle. Electric motor equal expensive. Speed controller expensive. Yeah, this might be true, but you still have to remember how much you're gonna. I calculated how much gas money I would spend and how much I would save. It was like $2,000 a year